You step into a warm shower and pull the curtain shut, only to have the bottom of the plastic liner start creeping toward your legs as if it has a mind of its own. It feels like a strange draft is blowing into the tub even though the bathroom door is closed. This happens because the fast-moving water droplets drag the surrounding air down with them, creating a localized zone of low air pressure inside the shower. Higher air pressure from the rest of the room then pushes inward to fill that gap, forcing the curtain toward you. It is a daily demonstration of fluid dynamics, showing how motion can literally change the weight of the air around us. Even a simple morning routine is a delicate dance between pressure and flow. When you whisk a clear, slippery egg white vigorously, it transforms into a stiff, white, cloud-like foam. This dramatic change isn't just about adding air, it's about unraveling proteins. The egg white contains long, coiled protein molecules. Whisking stretches and unfolds these proteins. As they unravel, their sticky, previously hidden parts grab onto air bubbles and, crucially, onto each other, forming a stable network that traps the air. The white color comes from light scattering through all those tiny trapped bubbles. The same reason clouds are white. You're not just mixing, you're performing delicate structural engineering at a microscopic level, building an edible, air-filled scaffold. When you stand up after sitting for a while, the seat of the chair feels distinctly warm to the touch. It feels like the chair absorbed your body heat, and it did, but there's a deeper twist. That warmth isn't just heat transfer, it's also a story of insulation. Your body is constantly generating heat. The cushion and fabric of the chair are poor conductors of heat, so they trap a layer of warm air and slow down the escape of your body's warmth. When you stand, you're not just feeling heat left behind. You're feeling the absence of your own insulating effect, the ghost of your thermal presence imprinted on the material. The chair didn't get warm, it kept your warmth close. You are getting ready for bed on a cold, dry night and pull a fleece sweater over your head, only to hear a series of tiny pops and see bright blue flashes in the fabric. It feels like you've accidentally created a miniature thunderstorm right against your skin. This happens because your body and the fabric have been trading electrons through friction, building up a massive imbalance of electrical charge. When the gap becomes small enough, the electricity leaps through the air in a sudden discharge, heating the air so intensely that it glows and creates a tiny shockwave of sound. This is static electricity, the exact same physics that creates a bolt of lightning, just on a scale a billion times smaller. It is a startling reminder that we are electrical beings living in a world full of hidden energy. When you hold a large, curved seashell up to your ear, you hear a soft, roaring sound like distant ocean waves. It's a magical experience, but the shell isn't capturing the memory of the sea. The shell is acting as a resonant chamber, amplifying the ambient noise that is always around you. The air moving in the room, the distant hum of appliances, the sound of your own blood flow, all of these quiet sounds are normally filtered out by your brain. But the shell's shape catches these whispers, reflects them around its hard, curved interior, and funnels them into your ear. You become aware of the hidden soundtrack of your environment. The ocean you hear is the sound of listening more closely to your own world. When you clean a glass window or mirror very well with a cloth, your fingers might produce a high-pitched squeak as they slide across the surface. This isn't the sound of friction, but the opposite. A perfectly clean, dry glass surface is incredibly smooth at a microscopic level. The squeak is a form of stick-slip vibration. Your fingertip or the cloth fibers briefly stick to the ultra-smooth surface due to molecular attraction, then suddenly slip, then stick again. This rapid, microscopic sticking and slipping creates vibrations that travel through the glass, which acts like a speaker, amplifying the sound. The cleaner the glass, the louder the squeak, a sonic proof of a surface, stripped down to its smoothest self. On a dry winter day, you might reach for a metal doorknob and feel a sudden, tiny zap on your fingertips. That miniature lightning bolt is a static electricity discharge. As you walked across a carpet, your shoes rubbed against it, stripping tiny, negatively charged particles called electrons from the carpet and depositing them on you. You became negatively charged. The metal doorknob is a good conductor and is neutrally charged. When your finger gets very close, the excess electrons jump across the gap to the doorknob seeking balance. The spark is that rush of electrons, and the zap is the feeling of them moving. You just completed a circuit with the world, feeling the invisible force of charge seeking equilibrium. If you've ever carefully sprinkled a few drops of water onto a hot frying pan, you've seen and heard it. The water doesn't just vanish. Instead, it beads up and skitters around the surface for several seconds with a loud, fierce sizzle before disappearing. This happens because the bottom of the water droplet instantly vaporizes when it touches the hot metal. The steam created lifts the rest of the droplet slightly off the surface, forming a protective layer of vapor that the droplet rides on like a tiny hovercraft. This is called the Leidenfrost effect. The sizzling sound is the violent escape of that steam. So, the droplet survives longer on a very hot surface than on a warm one, skating on its own tiny cloud. It's a brilliant little dance between liquid and heat happening right in your kitchen. On a chilly morning, you exhale and see a cloud of steam billowing from your mouth. It looks like you're breathing out smoke, but it's a cloud of liquid water. The air you exhale is warm and saturated with water vapor from your lungs. When it hits the cold outside air, that vapor can no longer stay as an invisible gas. It rapidly condenses into billions of tiny liquid water droplets, just like a cloud forms in the sky. You're not seeing your breath, you're seeing a personal, temporary weather system, a miniature fog created by the sudden meeting of your inner warmth with the outer cold. You carry your own humid tropical climate within you. You hear yourself talk every single day, but the moment you listen to a recording of your own voice, it sounds strangely high-pitched and unfamiliar. You might even think the recording sounds wrong, but that version is actually what everyone else hears when you speak. When you talk, you hear your voice through two different paths, through the air and through the vibration of your own skull bones. Your bones act like a natural filter, boosting the lower frequencies and making your voice sound deeper and richer to your own ears. A recording only captures the air-conducted sound, stripping away that internal bass. It is a personal lesson in how our physical bodies shape our perception of reality. We are all walking around with a built-in sound system that only we can hear.